Okay, welcome everybody online and in the room. I'm Dee Frawley. I'm the program manager at CSIC, and I'm here very delighted to introduce our speaker today, Dr. Jinying Xu. Dr. Xu's been a Marie Skłodowska-Curie Fellow in the Department of Engineering since September of 2022, and is currently part of the Future Roads Fellowship Program, working on the project Data Science and Digital Technologies for Intelligent Carbon Management in the Whole Life of Highway Assets. And that's in collaboration with industry partners, National Highways, Costain, and SAP. And the project's aim is to develop a standardized carbon metadata model for the digitization and automation of carbon data management, measurement, and reporting, to collect trustworthy data that facilitates informed carbon management decision-making in highway assets. And the project supervised by Dr. Christian Haskell, here with us today. Before joining University of Cambridge, Dr. Xu worked as a postdoctoral fellow at Hong Kong University and was the research team leader and then a project manager for a £1 million Innovation and Technology Fund project that integrates BIM, IoT, and blockchain for quality assurance for modular construction, logistics, and supply chain management. She's won the 2021 Building Smart International Award in the professional research category and the 2022 ASCE Journal of Management and Engineering Best Paper Award. She received her PhD in Smart Construction Management at the University of Hong Kong in 2021, her MPhil in Construction Project Management from Chongji University in 2017, and Bachelor of Engineering in Engineering Management and Bachelor of Law in Sociology from Harvard Institute of Technology in 2014. So we'll be speaking today on carbon management in the highway sector towards data trustworthiness. Please welcome Dr. Xu.
For the introduction, and thank you for CSIC's invitation to give me this opportunity to present to my research. I've just get started since it has already introduced me all my track record, so I will just read this. Yeah, so maybe I would like to explain a little bit more about my research mission as a researcher, not just from this program, but as researcher in the construction project management area. Since we are entering the digital era, construction projects, like the digital technologies, are being adopted in construction projects, and it forms like our world is a cyber physical social system, and the construction project itself is a small cyber physical social system. That's my world view. And we have in the cyber world we have data flow from different aspects or different systems, different processes, and in the physical world I have materials flowing from raw material to different stages and finally our buildings and infrastructure, and in the social world we have process flow, the management and the coordination of the social activities that forms the process flow. And I aim to look at streamline the different flows in this CPSS system. And what I always try to answer the research question of how to adapt the data process and the material flows in the CPSS construction projects to modern construction methods and digital transformations. Because the construction industry is quite a traditional industry, which is very reluctant to change. It has its own data process and material flows, and the introduction of modern construction methods and the digital transformation have introduced new flows, which we have not very well fusioned or integrated. So that makes things more complex, and it causes a lot of chaos, as I can see. So I try to look at this problem in my whole research, and I have looked at the data flow by integrating IoT, BIM, and blockchain using this digital technology to bridge the data flow between the cyber, physical, and social subsystems, and to achieve data-driven decision-making and cognitive intelligence by streamlining the data flows among the different subsystems. And also, I looked at the process flow of construction digital transformation, see how digital technologies shifts the process flow of construction project organizations. And also, I looked a little bit at the material flow by looking at the waste materials, and now at the carbon, because carbon is also associated with the material flow. So that's how my whole research landscape looks like. And I think human plays a significant role in this system. And how do we adopt technologies while considering the humans' requirements and the learning curves, and how to ease the works and make make the system more friendly and digitalized or automated for the ease of humans, or to assist humans, to augment humans. That's something I would like to achieve in my future research. And so enough about me. And then this is the outline of my talk today. I'm aware that maybe the audience is not all in this carbon related area or highways, so I will start from a general introduction, but the infrastructure sector is its impact on net zero and the carbon management standards at a higher level, and then dive a little bit into the highway industry, the practice that I learned from the engagement with national highways and its network, and identify the gaps of and the need of trust, and then present the work or the concept we proposed called the carbon data trustworthiness, and how the conceptual framework or model looks like, and what we try to achieve later. And so that's the research and industry engagement plan will conclude this talk. So I think everybody knows that there's like an urgent schedule for us to achieve net zero by 2050, and by 2030 we had that's the middle of it. We have a very huge emission gap. It's like we need to use around 100 to 200 gigatons of less. We need to reduce 12 to 33 gigatons of CO2 equivalent, which means we need to use 100 or 200 gigatons of less of the reinforced concrete. And that's a lot of things to do, and to achieve to minimize this gap, and we need to have data-informed decision to support us to achieve this goal. But that means we do need more reliable data to support us in the decisions. Otherwise, how would we know if we can achieve this, or how far how good or how bad can we do? So and the infrastructure plays a significant role in the climate change, or influence the sustainable development goals. And you can see that all these infrastructure sectors combined, they influence 92% of all the targets of the SDGs, and the infrastructure contributes to a total of the GHG emissions of 79%, which is like a lot. So we need to do action now, and action we need to act like join our forces. And there are lots of carbon management standards and guidelines being developed. The most famous, or like the most widely used one, is greenhouse gas protocols. So they have a set of protocols for countries and cities and communities, as well as companies and organizations. These are all like more overall high-level greenhouse gas, like CO2 management standards. And we also have a lot of international standards that are listed here, and maybe some of them are, and also national standards in like the BS ones in the past 2050 or 2018 ones. These standards are more focused on the life cycle assessment and the LCA, environmental product declarations, EPD. They are about the principles and frameworks and requirements and guidelines, and some of them are methodologies of the overall environmental or sustainability assessment of general products or about construction works. And unfortunately, because of this, some of this, most of the standards are not free, so I haven't really looked into, investigated into them. But the other standards or guidelines that I'm looking for are based on this. So I think that this is like overview for you. And for the, as I mentioned, there are different levels of these standards. At the organization level, they have all these different standards, but most of them are focused on the broad and the multiple impact category, which means they're not like very focused on single scopes. And talking about scopes, I have to introduce the 3 scopes of the emissions defined by the GHG protocol. So these are the 3 scopes. Scope 1 is a direct emission from the company, from their facilities or the locals or the direct manufacturing or production. And the scope 2 is indirect cost that is purchased from the suppliers, including the purchased energy, heating and cooling, and spins like this. And the scope 3, which has all these 15 categories. And scope 1 and 2 are mandatory for companies to report, but scope 3 is not mandatory now, and we are not doing very well in quantifying scope 3 because there are so many different categories, different things to consider, and it's both if you need to both you investigate the upstream activities and the downstream activities. And this is another way to look at the 3 scopes. So if you look, like if a company has different products and can see how the 3 different scopes stems from the life cycle of their products, and adding them up, we can have the total emission of one company. And also there's another methodology to accounting carbons, which is a life cycle carbon modules of projects and assets. I think this is more focused on project and assets. So it categorizes the carbon into embodied carbon, operational carbon, and the user carbon. And these modules are adapted from the BSEN standards and the PAS 2080, which I will articulate later. And this also links to the EPB, which sometimes calculates just the cradle to gate or cradle to grave. So for the A1, which is raw material supply to a and then A2 transportation and S3 manufacturing, that's the cradle to gate, which means from raw material to some products of the side of the maybe for construction industries, the construction side, and to the gate of the construction site, and then we have construction activities which will impact on the site or like the practical implementation. And we have the in-use stage, and after the when it ends, we have the end of life calculation, and then everything is deposed. We have we then enter to the grave stage, and another methodology is a product carbon footprinting. So this is more focused on the product, the 7 stages of product's life cycle, from its exploration to the end of life. And this also can be connected to the different scopes of the GHG protocol. And also here, I want to maybe to remind you to think about to link the 3 different methodologies, like the 3 different scopes. That's for company, but some companies, and then the 3 the life cycle modules, the A1 to A5 and B1 to B9 to C1 to C4 of the life cycle projects, and also these product ones. I think there are the different lenses to look at the carbon emission and accounting, like different scope, but they can be sometimes they can be related to a lot of ways. Like in our construction industry, a project is to deliver a product, like a highway or building, that's a product. And organizations are sometimes project-based organizations. So there are like the interfaces between these different ways or different lenses to look at this. And I think we need to streamline it and to be more clear about to streamline the interfaces among these different methodologies. And yes, this is we also have a lot of standards for even for the PCF. But I'm not going to introduce more. And this is how to calculate the whole life carbon of a product of projects. But I also try to map it with the PCF stages. And there are also the requirements across project life cycle modules. For the early concept design stage, we can just make predictions of the general value based on our previous or historical data, but this cannot be that accurate. And then when we have the technical design and when enter to the construction stage, we can calculate the carbon based on the actual values. What I want to emphasize here is that there is a lot of complexity in collecting the actual values. So, like on the one hand, there are a lot of uncertainties in the predictions, and on the other hand, there's a lot of technical and managerial complexity in collecting the actual values. So, ideally, we can calculate the whole life cycle carbon using all those different methodologies, but in reality, it's very hard to get the reliable data to support our decision making. And that's what I've been introduced before, all the standards are like more general. And now I'm going to narrow down to the standard for the carbon management in infrastructure, or so you must have heard about this PAS 2080, which is widely used in the UK industry. So we have an updated version of this in this year. So it's include the buildings in it already also. And this one, the guidance document for PAS 2080, if you are looking in this the carbon management area, I think this one is more detailed or specific for how to do it, some the ways. And yes, so these are just some key terms to help you to know, to understand what are the difference like we're talking about. Capital carbon, which is also sometimes called embodied carbon, it means the creation and end-of-life treatment of an asset. And operation carbon is operation of an asset, and the user carbon, which is the user's utilization carbon. But we can see that in capital carbon, sometimes we also calculate the maintenance and refurbishment and the operation. Is to enable the operation and deliver of services for the utilization. So we can see there are some overlaps between these three categories of the carbon in the infrastructure. But like where is the scope of this depends on the methodology you're using, and some other terms which is not very significant to this talk. But if you look into the carbon calculation, you should be aware of those. And so the new PAS 2080 is expanded in scope to include not just infrastructure, but also buildings. And it's focused on behaviors and good practice principles intended to for the whole industry. And it looks not just at assets, but also the systems, networks, and the whole system of systems sometimes. And it's more emphasized on the importance of leadership, governance, and collaboration across the value chain and beyond. And also including the guidance for government regulators and financial risk. And it's encouraged a consistent approach across the built environment industry, but which means it did not provide this consistent methodology. It just encouraged other companies, organizations to create this. And it emphasized that, well, we should not have conflict with other existing standards and schemes and notices. So I think we're still like, I want to highlight this consistent approaches, because what we this standard developers may also realize that there is currently no consistent approaches. That's what we're trying to do here. And more about what is not about. So yeah, it's more about the process of the carbon management among the network, among the value chain network. But it's not about the prescribed quantification or assessment methodologies and data gathering. Yes, so a lot of companies are referring to this, but they cannot find the quantification or assessment methodologies here. And because they said like this is already addressed in other standards, specifications, which to refer to some of the standards I have summarized before, including the ISO 14044 and the other ones. But those methodologies are I have looked into them, but I would not say I'm an expert of those standards. They are all, as I said, they're more on the LCA or the EPD, which is not more about the data itself. It's about the how to quantify the carbon in products or in construction works. And so this is also a figure from the past 2018. It shows the degree and accuracy and availability in the whole life carbon assessment across the work stages. So yeah, of course, at the earlier stage, we have higher ability to reduce the whole life carbon, but we don't have the level of data or level of data, we just have low level of data availability. And when we have more data, that is keeps generating at the later like design and delivery stage. We already have very limited ability to reduce carbon. But what I want to say is that if we can, even though maybe we cannot reduce the whole life carbon at the later stages one project, if we can collect this data, this can be used for other projects, later projects. So it's still we need to extend get the data right for the feedback or the fallback of the whole industry. And these are some of the typical emissions and that was listed in the past 2018, and this transport infrastructure related. So what you can see is like just some points, which is very broad and general. So I didn't see like stakeholders can refer to this to streamline the carbon calculation methodologies, or like what they should do or not. So now, since my project is focused on the highway industry, I will introduce more about this. So about national highways, they have their net zero plan. They would like to achieve the corporate emission, zero corporate emission by 2030, and net zero by 2040 in maintenance and construction, and the road user emission net zero goal by 2050. And these are the kind of the activities they are doing to push through this. It's just for background. And so they also have some different strategies and plans, like this carbon construction innovation program, which aims to identify and define the challenges and opportunities for innovations. And the carbon management system, which I've heard them talking about, and is still in development. I think it's an overall management frameworks or system, something they want to oversee the carbon management. And they also have been developing different libraries and tools. So this National Highways carbon tool has long been used by its construction and maintenance contractors in the National Highways supply chain. You can see that this is a spreadsheet form, which it has different modules for contractors to input the project details and the data. The project details and the modules are different categories, including like the bulk materials, earthworks, and loads of them. And this is how they input the data. So they need to input an item and select to its type, and also type in the quantity, and also look at the carbon factor, and then the tool can have it to calculate the carbon emission of one single item and the total carbon emission. That's how it works. So having been talking to a lot of frontline engineers about collecting this data, they all said that it's very hard to get this data, and it's hard to chase people to get the data they need, because this is like a they need to do this report in a 3 months basis. So when things already happened 3 months ago, people didn't have the record of what happened and all this detailed information. So they can only make some maybe best guesses, or there are a lot of information that's not reported, not recorded and reported. And they also developed something called low carbon opportunity register, which they have identified 115 opportunities about the low carbon opportunities, which I cannot really say, but it is like for maybe low carbon material or some low carbon, like one item is one opportunity like they have identified. And then it will like clearly record what the opportunities type and the carbon reduction in what category and to what extent, and the applicability to other projects and all these kind of things is on a SharePoint online. I'm not sure if it's I don't think it's publicly available, and I haven't. Okay, so here comes to the gap. I will need to look at now. So we all know that construction value chain, we have like a very prolonged value chain with both stakeholders. So if you have played this telephone game, or they call it Chinese whispers, you know that when the value chain gets longer, you tend to get the wrong information. So that's why sometimes like then the backend turns to be the big information. That's and bear in mind that there are so many data to be required for carbon calculation, including the activity data and the emission calculator data. There are so many different activities that we need to consider, and we have different choices of the emission factors, which so with all this, so many data required and for this, and with such a prolonged value chain, you cannot say it's hard. It's hard to get the information wrong. What we try to do is to develop a fundamental carbon data model. We could make it available for an intelligent carbon management system, and to increase the trustworthiness of mission intelligence of carbon data reporting. And this example carbon data flow we identified, which actually you can also refer to the PZF stages that another table has shown. So what I want to emphasize is that data availability and quality are the two major problems that we identified through this the interviews and the industry engagements. And the current methods to do this is laborious, unreliable, and not valuable for us to do decision making. So we proposed this concept of carbon data trustworthiness, which we identified the carbon availability, quality, compatibility, and security as the 4 key pillars to achieve it. And then identified the key principles and the technologies to achieve this, including if we want to have more of the wider availability of data, we need to have standardized data structure, clear stakeholder responsibility, and streamlined data collection procedures. And all these different different technology and principles. These are a bit of the high level. We propose this digital carbon management system framework. So we would like, we are aware that actually there are data in different forms or in different, they are here and there in the forms might not be designed for carbon accounting or calculation, but they are somewhere there, like the B models or the bill of quantities or some of the set logs, or they have the procurement database, CRP database, and then they're using some of the IoT systems. So all this data can directly or indirectly be used to calculate the carbon. We don't want to add extra burden to collect the data or to increase the cost of collecting data. So what we want to do is to help to develop this carbon metadata structure that we can integrate or mine this data from these different sources to a centralized carbon register library, so that we can transform all this data from different sources in different formats into a standardized format. And then after we have the standard data, we can unlock a lot of potentials of big data analytics, AI, machine learning, and then I'll go about of decision-making applications. And the ongoing work I'm doing now is to review and sort out the ontologies and categories under the work breakdown structure, and to map the key areas, and also compare different libraries. What I introduce is some of the national highway libraries, and I also get access to some of the Costain's WBS and carbon libraries. So I'm trying to compare them and identify the high-level map to the work breakdown structure, and then identify the metadata required for carbon calculation. And also I'm doing some interview to confirm the key challenges in the carbon management system architecture, the system architecture, and the carbon data collection procedures. Try to use this metadata structure and all this our model to streamline this data collections. And so for the future work, we will try to do this more about the academic part. We will develop the carbon ontology for highways, and develop the carbon metadata structure by engaging industry collaborators, and also study the data requirements for digitalized or automated carbon management for highways with the use of BIM, and streamline carbon data flow along the whole life of highway, and data fusion methods for carbon data from different sources. And if like engaging with the industry, we will test the proof of the concept of this system, and yeah, it's supposed to work. And so I was very bad at the time management, because try to talk to cover a lot of the topics that are related, because it's a really broad thing. So I have went through the carbon management standards, including the GHG protocols and the international and the national standards, and the 3 key methodologies that we are using in different scopes for the carbon accounting. And also just a little bit about the PAS 2080, which is the key guidance standards that we are using for the highway and for the infrastructure and the building sector. And also quickly went through some of the national highways practices, from its structure to the tools they're using and the gaps. And then very quickly run through the trustworthy carbon data model we're developing, and summarize some of the work we try to do. And I'm aware that I didn't explain very well a lot of the details, so welcome to talk to me. We can discuss more on those details, and if in one way or another we can collaborate, I'm very glad to. Thank you.
Thank you very much.